Hello, in this tutorial I'm going to use the stack again. In the last couple of tutorials we developed the stack which was totally dynamic. Now we are going to use that in this tutorial as well. Here you can see that we have a file input_text.txt that contains some text, and the purpose of the program is going to read this content and is going to write the content in reverse order in another text file. So here is the program, and we have this function reverse it that's going to receive the source file name as well as the destination file name, and it's going to open this file in read and write mode, and it's going to read the content of the source file and push each character into a stack, and then the stack is going to be popped and each character is going to be written into the destination file. In that way the destination file is going to contain the characters in the reverse order. So we have called this reverse it function by passing the source file name. Here you can see that the source file name is input_text.txt, and that's there in this folder data_file, which is under my users directory, and the destination file name is rev_text.txt. The reverse it function does the job, and if it fails it returns 0, and otherwise if it is successful it returns 1. So we are checking whether the value of f is 1 or 0. So if it is 1, then the file copy was successful. We are printing a message to the console, otherwise we are printing an error message. So let us complete this function. We have this stack APIs as usual, but only one difference is there. Since we will be dealing with character, so I have declared the pointer here within the structure as character pointer. Earlier it was integer pointer, and we have changed the parameter here in push function. The push function is now going to receive character and the pop is going to return character, and also the allocation is going to take place for the characters. So the malloc function is actually allocating according to the size of character. Here you can see that it's size of character instead of size of integer that we used earlier. So everything else remains same as far as the logic goes. They remain same. Init function also allocates the character. So all the other things are actually exactly same. So let's complete this function reverse it. I have opened two file pointers. You can see that we have taken two file pointers here, fps for the source file and fpd for the destination file, and I have opened the file using the fopen function. fps is opened by supplying the source file name with path and the mode, that's going to be read text mode, and r is the character for that purpose. And I did the necessary file pointer checking whether the file has been opened successfully or not. If unsuccessful, we are returning 0 to the caller. Similarly, we have opened the destination file in write text mode by supplying w here, and the destination file path here as the first parameter, and we did the necessary file checking as well. Now we need to go on reading the content of the file, and we need to push the character into the stack. So I'm declaring a stack here. Let me initialize the stack. We have declared a constant here size, that's initially 50. That's the size of the stack initially, and if overflow happens, the stack is going to be doubled automatically in the push function. We have taken care about that thing earlier. So now let me declare a character variable in order to store the character read from the file. So I can go ahead and read a character by calling the fgetC function. fgetC reads a character from a text file. We need to supply the file pointer here. The file pointer will be automatically moved forward after reading the character. fgetC is going to return the character that is read from that file pointer. Now let me go ahead with the loop. As long as it's not end of file, we need to read from the file. If it is not end of file, then we can just push the character into the stack. So this is the character that was read, and then we can go ahead and read the next character. So when we come out of this loop, all the characters from the file has been read and they are pushed into the stack. Now what we need to do is to pop the stack and write the character into the destination file. So while not is under flow stack, we need to write the content that is popped from the stack into the destination file. So for writing, the function is fputc. fputc receives two parameters. The first parameter to the fputc is the character that we intend to write, that we should get from the pop function, and the second one is the file pointer where this is to be written, that is fpd, the destination file pointer. So this particular while loop will write the content by popping the stack and to the destination file fpd. At the end, we should close both the files. And we should deallocate the stack because we are done with the stack. So I can just call the deallocate function in order to deallocate or free the memory. And then we should return 1 to the caller in order to tell the caller that the function has done the job successfully. So we are done. Now let me go ahead and run this program. I'm opening the Finder side by side so that you can view what is happening there in that folder. The destination file is going to be created, ref_text.txt is going to be created here. That's going to contain the reverse of this file input_text.txt. So let's go ahead and run the program. So you can see that file copied successfully and ref_text.txt has been created. Let me open this file. So you can see that it's the exactly reverse of this file input_text.txt. So without the stack, this program would not have been possible. So we have used the already developed stack in this program. Now all modern day languages like Java or C#, they comes with inbuilt stack in their library, and you don't need to build the stack API for your purpose. But in C, we need to develop this. So in the next tutorial, I'll be giving another example where we will be using the stack APIs, and we will be checking an expression, whether the brackets given in the expression are well formed or not. That's an interesting one. So thank you for now.